So Davo and I have been speaking about the best way to showcase the NEXUS R5 series ECU with all its features and functions, and we figured what better way, instead of doing it on the bench and mucking around, than to get a full-fledged circuit car here to do an install, tune, configuration and setup. And what do you know? We got one.
Yeah, no worries. I've got it. It's all good.
The Nissan R35 GTR was unveiled in 2007 at the Tokyo Motor Show. It's the first GTR to be promoted without the Nissan Skyline badge. Powered by a 3.8 litre twin turbocharged VR38 DETT V6 engine, they made 421 kilowatts or 564 horsepower. In 2015, the HKS GTR became the fastest time attack GTR, setting new lap records at Fontana, California, Fuji Speedway, Japan, and in Sydney, Australia, where the car set a new GTR lap record during the World Time Attack Challenge. That record stood until 2017, when American team Life Motorsport broke it in their highly modified R35 GTR. Life actually damaged more than just that record. They also damaged their main engine in practice, and by a stroke of luck managed to secure a replacement engine from another World Time Attack competitor and set the new record using the replacement engine. After the event, the said engine came out of Life's race car and went back to its previous owner. Now this is where it gets interesting. The guy who lent Life Racing that R35 GTR engine is our mate, Brian Bew. Brian Bew also happens to own this R35 car and that VR38 engine, which is the same engine.
All right. Oh, so this is the engine that actually broke the HKS record.
That's it. Huh. So at Time Attack, their engine died. They went out, they found that VR38, they grabbed it off Brian, borrowed it, put it in the car, set that lap record. That Sunday, it got thrown in a container, boom, off to America. Cole from Life Racing, the gentleman that he is, pulled the engine out when they got to the States, put it in a container, shipped it back. Brian put it back into this car. Here we are.
So I can't help but notice that there is, so far I've counted a total of 4 wires in this car, and that's 2 on each thermofan.
I told Brian that this would be an ideal R5 test car for us to be able to get dirty with it, to be able to configure everything. And I said, mate, don't worry about the condition. Perusic Engineering are the guys that have done all the fab work so far, and it's pretty much finished. All it needs is all the wiring, configuration, tuning, and that's it. So Davo, slap some wires in here. We know how quick and easy it is to do that. What a car to be working on. Right, so for this adventure, we're actually not going to be using that many components because the heart of it is the NEXUS R5 that's got the PDM, it's got the wideband, it's got heaps of I/O already into it. The components we're going to be using are one of these 15-button keypads, awesome little thing. We've got some battery connectors that go straight onto the NEXUS. We've got the Haltech IC7 dash. We've got a whole heap of sensors that are going to be going into this thing because obviously having the NEXUS running it, we do want it to be displaying everything across the IC7 dash. We want to make the most of the data logging in the ECU. We've also got a whole bunch of bulkhead connectors to do a heap of wiring stuff, but that's not really my domain. So we're going to throw it over to Davo, who's going to talk a bit about how we're wiring the NEXUS into this car.
The R5 is going to change the way that we wire cars from now on. Because of all the power distribution that comes from this unit, we don't have to wire up separate fuse boxes or separate PDMs in all different places in the car. We can do it all from this central position. So this is going to be in the car, and I'm sort of riding on the firewall of the car at the moment. So all of this stuff will be inside, all of this stuff will be outside. So the way we're going to merge the factory harness that we've got and the Haltech harness that we've got, we're going to do it all through these bulkheads here. So we're going to do one side with a body loom and the other side with an engine loom. we've got our factory wiring harness here with our factory R35 coils, our drive-by-wire. I've added in a whole bunch of different pressure sensors as well. So we're going to be using the Bosch pressure and temperature sensors. We're going to use as many as we can on all the different parts of the engine to get a good picture of what's actually happening out on the racetrack for diagnostics and data logging. We've got an injector loom here as well. We've got our headlights already wired up the front there to those two big Deutsch connectors. So they're going to run the headlights, the blinkers, the high beams, and the parkers in the car. We've got our widebands up here as well. Crank sensor, cam sensor, all that stuff's all routed through here already. We've got two more pressure sensors out on the edges, as well as shock travel. We've got a few wires coming across for the dash and any other switches or anything like that that may already be in the car. We may not even need any of these because we can use our CAN switch pad for all of that sort of stuff. This is our main engine stuff, which is going to go through these bulkheads. So that'll be one of the next jobs that we have to do. And this section here, we're actually going to run all the way to the back of the car and put that through another set of bulkheads, which is going to be really, really handy for doing fuel pump triggering. We can do tail lights and brake lights through these as well. So it's going to be fairly comprehensive and a lot of fun.
One of the best things about working on a dedicated circuit car is that there's normally enough holes in the firewall for all of our stuff to go through, and the guys that have built this car have put enough holes in the firewall for all of our stuff. All I've got to do is just make this one bigger on this side for one of the battery bulkheads to come through. So here we go. Righto, well first things first, we've got a hell of a lot of planning to do. This is a highly technical engine that's got variable cam control solenoids, got variable cam control phases. We've got a heap of extra sensors that we want to add to be able to do a bunch of data logging stuff. So, Davo, planning out the harness, what do you think? Where do we start?
There is nothing worse than missing a wire, particularly when we're going through a bulkhead. Adding a wire back into that afterwards is a little bit painful. So if we use the software versus the list of inputs that we know that we need to run, plus some that we might want to run in the future, that makes it just really, really easy to just get it all done right the first time. So we can try and do that together.
All right. Well, here's my list that I prepared earlier. This has got our wish list of the stuff that I want in this car. We've got a NEXUS R5 in front of us, and I've got my laptop here with the software installed. So the first things first, this is one of the big differences with the NEXUS system. I'm going to plug my USB cable into my laptop. I'm going to plug the USB plug into the NEXUS. Oh, I love this bit. I love it. My little status light comes on, goes green. We can now communicate with the NEXUS ECU straight off our laptop without powering it. So this is awesome for doing configuration stuff, and even better for loading base maps before you send one of these to a customer or to one of your mates. Well, let's get to it. We'll open the software, Haltech NSP. Because we've got our USB cable plugged in, straight away it's gone online. It's read the definition file out of the ECU, so no internet connectivity there to do that. Straight away it's online. That took all of 6 seconds or something. The first thing that I notice in the software here up the top, since I've grabbed this ECU, my little green icon button here, firmware upgrade available. So I'll click on that. Does a firmware upgrade on that ECU. So that's going through now and doing that update. So that's probably one of the biggest things about the NEXUS stuff, where we're always doing software updates and always doing firmware updates. The NEXUS software actually lets you know when there's a software update or a firmware update available. You can either choose to do the update straight away, or you can put it off till it's convenient for you. Before we go further, one of the things to note, in the top left-hand corner here, our connect or disconnect button, notice the yellow with the little USB signal. So what that's signifying is that Yellow means that we're connected to the engine management system through the USB cable. There's no data displaying on the screen. That's because the ECU knows that it's connected via USB and it knows that there's no power and no ECU sensors connected. So it's not going to display any engine data at the moment because connected via USB for your convenience. The first thing that we need to do, I suppose, is go through and figure out what type of engine we have. Pretty straightforward again. The first tab along the top here, engine configuration. We click on that. Engine capacity. I won't bore you to death with all this stuff, but a lot of this engine configuration, the trigger system, the fuel system, the ignition system, for this particular car, we'll set it all up as the VR38 twin turbo, twin electronic throttle engine.
So we've got a 6-cylinder, so we know we need at least 6 outputs for our ignition coils. Starting with ignition, just because it's on the top of the pile here, so we'll at least grab the wiring colors from the software as well for our ignition setup. Using R35 coils, funnily enough, which is great. We're just going to pick the 6 wires that we need, and we know that we need a power for those as well. The power's actually all integrated within the actual unit itself, so we don't need to run an extra relay or anything like that, so that's really, really easy. That we can just group that and run those coils with that.
While you're doing that, in the software here, a couple of things I'm going to go through while you're pulling that apart. I'm just setting the software up the way that I like it. One of the first things I'm going to do, navigation tree text size. This is one of the things that, for me, I recently got my eyes lasered because I always wore glasses and I couldn't see all of the tiny text on the screen. So one of the things that we've changed in the NEXUS software, you get to choose the font size of the ECU navigator and the map space that you're actually tuning. So the first thing I'm going to do is crank my text size up to 10 or 11 so I can actually see everything and it doesn't put strain on your eyes. Then there's a little mode here that's pretty handy. What it allows me to do is turn on all the tree nodes. So in the way the software works, it actually now allows me to show every sensor that the ECU can take in, the ones that are turned on and the ones that are disabled. So the software works in a little bit of a different way where if the sensor's not turned on, we don't display it there for you to see. So basically when you're tuning the engine, you can see everything that's connected and configured and nothing that's not configured. It makes sense as to not confuse anyone. When we turn this mode on, it's really nice what we're about to do, going through and setting up all of our sensors. I can simply go through our sensor list, right click on what I want, enable it, put it on whatever wire Davo says that it's going on, then our pin assignment's done. Now, while Davo's separating some of the wiring, I'd like to go through a bit of the idea behind how the NEXUS system actually works. The best way to do that is to set up in the software, and one of the things I'm going to do is set up the fuel pump strategy for this car. Sounds like something that's pretty straightforward because, well, normally it is. This thing's got 2 pressure pumps, it's got a lift pump, that's about it. But here's where the magic happens with this car. It starts to get complicated when we want to stage the fuel pumps, we want to be able to turn the lift pump on to be able to fill the surge tank, and we want to be able to pump fuel out of it while it's just sitting there. We might want to be able to be, say, pumping E85 out of it. We might need to do a fuel test on it, something like that. So instead of wiring in all extra switches and wasting a heap of Davo's time, enter the 15-button keypad. A really, really nice keypad. I'm sure that you've seen these around before. It mounts really easily. We're going to put one of these in this car. It's got 4 pins on the back, plugs into the Haltech CAN network straight into the ECU. Then we flick over to the software and see how it's done. So the first thing I'm going to do, we'll scroll down through our huge list of functions here and go to Connections, Haltech CAN System. Down the bottom here, we've got wideband controllers, which I don't think are going to be used that much on this system, only that it's got dual on-board LSU 4.9 or NTK sensor control anyway, so no external wideband controllers. Extra input-output expanders. This thing's got so many inputs and outputs that you may want to use an I/O expander, like maybe if you want to mount one in the back of the car or somewhere else. In saying that, I really don't see a huge need for that at the moment. dyno mode, which is basically to be able to connect the dynamometer CAN network into the Haltech ECU so the dyno and the Haltech can share all that information while you're tuning the car. Thermocouple amplifiers. These are ones you might use an 8-channel thermocouple amplifier and put it in the engine bay so that you can measure EGT or high temps out of turbos, something like that. The reason I got to this particular screen, I want to look at the keypads option. In this car, keypad 3x5. I'm going to turn that on. Not going to do any CAN addressing or any of that sort of stuff because the absolute truth is I don't know about that stuff. So I'm just going to turn that keypad on. I'm going to cruise all the way back up to my fuel pump setup. Let's go. Turn fuel pumps on. All right, so I'm going to have 1 pump, 2 pumps, and the first pump, the original pump. So how am I going to turn these things on and off? Primary fuel pump. I could set that up off a normal output, which would then ground a relay. That relay would then have power to it. That relay would then turn the fuel pump on. Instead of doing that, because this thing's got the built-in PDM functionality, I'm going to scroll all the way down to the bottom here. And our little lift pump, I'm going to put on an 8 amp high current output. I'm going to set it up so the fuse current on that 8 amp output, I'll just put it at 8 amps. I know that our little lift pump's going to draw about 5 amps. I will be able to see that current draw through the software when we get the thing configured, and I'll make sure that we're not running on the limit of the current. We've got how many times, if the fuse blows, how many times we want to retry. I don't know, 5 times. And we'll wait 1 second in between tries so that the thing, if it does trip and go over our max current rating, all it's going to do is try 5 times to fix the problem. If it can't, it's going to turn off and give me a trouble code that it'll display on my IC7 dash, and then I'll have to figure out what's going on. The second output is going to be a big pump. Do you know what pumps we're using in this?
I believe they're Bosch 044.
Okay, so for the configuration, let's set these up on some high current outputs. I'll set this one up on a 25 amp output. So the ECU is actually going to drive that Bosch fuel pump directly. That's right, directly. No fuses, no relays. I'm just going to say we'll set our current on that pump for, let's just say 25 amps. I don't know what it's going to draw. Our soft start current. What this is when a pump initially turns on, it has a huge belt to initially get the thing started. This is evident on thermofans and stuff like that. The soft start current limits that output, so it'll actually start the pump or start the thermofan slowly and then wind up to the current that we actually want. This is a really nice thing for things like when a big thermofan turns on and pulls a heap of current, you'll often hear a car's sort of idle note will change and it gets a bit stumbly at idle. This will stop that and help with the tuning of the car, as well as not just pulling huge current immediately for absolutely no reason. What I'm going to do for the time being, I'm just going to knock one of these off just so that we can sort of show what's going to happen here. The next bit I wanted to talk about here is our pump override strategies, and that's where I'm getting to with the keypad. If I click on here, I'm going to go through and I'm going to assign that second output. Then down here, our override input. If I edit this, we could have a fuel pump override that goes through a digital input into the ECU, through an analog input into the ECU, but that's all too much wiring. We've got a keypad. If I scroll all the way down the bottom of the screen here, I'm going to assign it to one of the bottom row of the keypad. So there's all of the pictures of which keypad I want. Bottom right-hand one. I'm going to double click on this. Done. The only other thing we need to configure for the keypad stuff is how we want the button to work. So whether we want it to be momentary, basically press it and as you're pressing it, that's when it registers. Do we want it to be push on to activate it and then push off to turn it off? So is it like a latching switch? And that's what I'm going to set up the fuel pump override as. So if I do push on, push off, and then we need the startup state, which is going to be off. So what that means is now, once this thing's actually started and running, If I press this button once, the little light's going to come up the top telling me that I've activated or I've latched that switch down, so the fuel pump will start running. I can drain the tank, I can do whatever I want. Once I'm finished, I press that button again. That'll turn the fuel pump off, and that's the end of it.
Beautiful. Question.
Yep.
It's normally my responsibility to make a speed-controlled fuel pump because some people want that for a really obnoxious fuel pump they've got in their car. You can barely even hear the engine. All you can hear is a fuel pump. So I often have to wire up a solid-state relay and then put in a diode, and it's just a lot of work and a couple of resistors just to keep everything in check. We can do this now directly.
Well, I'm glad you asked, Dave.
Excellent.
If we come over the software again, instead of having our digital switched output on our high current output, I'm going to click on that. I'll flick it down to digital duty cycle. Now that that's changed to digital duty cycle, all we do is flick over to here to our output number 1, our auxiliary fuel pump output table. This now gives us a duty cycle table. So it's an 8x8 table. If we put 0% in there, it will give us 0% of the available battery voltage. If we give it 100%, it's going to give us 100%.
So it actually works exactly the way that it used to in the old software, but now it's actually doing it directly from this connector.
Yeah, so the PDM stuff is
so good.
It's got built-in solid-state relays. It takes the guesswork out of all that stuff, and
the labour.
with any luck for you, and with any luck for me, the wiring complexity. So, NEXUS, new to Haltech, dual drive-by-wire throttle control, amazing. So, drive-by-wire, here we go in the software. Number of throttles, 1 or 2, okay, 2. That fixes that. Brake pedal check. So there's something here where brake pedal check, basically what that means is if you've got your foot on the brake, it'll only let the throttle go up to a certain amount. Just like a factory car, if you hold your foot flat on the throttle and flat on the brake pedal, it'll only open the throttle blade a certain amount. For race cars, for trailing braking, we typically don't use this function. What it's showing us here in the software, it's got an orange warning there. So orange being what we're going to try and perceive as less important than red. If it's red, that's bad and it needs attention. If it's orange, it just needs your attention, just to let you know that this is something that you just need to make a conscious effort that, yes, you've chosen that, that's fine, and we'll move on. If I come down here to drive-by-wire wiring, this is where we assign all of our inputs, as you know, Davo.
Beautiful.
So what we're going to do is go through and start assigning throttle 1 sensor A and sensor B.
Beautiful.
Our 2 drive-by-wire H-bridge style drivers. Then we've also need to assign throttle number 2, sensor A and sensor B, so that's 4 analog inputs. The second H-bridge, so that's 2 H-bridges or 4 individual wires altogether. And then we also need the pedal sensor A and pedal sensor B, so that's 6 analog inputs.
Beautiful.
Straight up.
Yep.
So analog input 1, 2, 3, and 4, we're going to be assigning for air temp, coolant temp, manifold pressure. The fourth one of that would normally be cable throttle position, so I'm going to wipe out our cable throttle position function because it's not being used.
Beautiful.
We'll flick it over to electronic throttle, and then I'll start assigning all of those.
Fantastic.
So here we go. So we're going to set up our dual drive-by-wire. And really, it's only a case of just double-clicking on the available channels. That's it. So that's the first throttle down. Geez, look how many analog inputs are there.
No more sacrificing.
Just which
Pick
sensor do you
and
want?
choose.
You just do them all.
So easy. Yeah, it's good.
Now we're down to the pedal sensor. Okay, that's it.
So
that's configured.
That's my assignment for that. Gearbox is probably going to be a critical one that we need to assign wires for. So can we have a look at that, what we need to do for this particular gearbox, this Albans
You know
one?
what? We should definitely speak about that. Just that remembering this thing does have an Albans sequential gearbox in it. It's a rear wheel drive car. We'll set up probably the position sensor.
So that's actually on the gearbox itself.
Yep. So that tells us exactly where the shift shaft is, what gear it's in.
Yeah.
It's got a load cell gear knob.
Beautiful.
So with those two things, we should be able to do closed loop flat shifting and downshift throttle blipping as well.
Oh yeah, on both throttles.
Both throttles.
That's pretty cool.
All right, let's
Sweet.
set that up.
Okay, no.
So the first thing we'll do, gear detection. Right click on gear detection and I'll go, yep, we want that. How do we want it? We want it on a gear position sensor. What channel do we want it on? The first available input. Done. Okay, flat shift. We may as well turn that on. Enable, load cell gear knob.
So that actually senses push and pull.
Yep, absolutely.
Both directions.
Yep, perfect.
Yeah, so it knows exactly which way. Yeah, cool.
Nice. Now, because we've got our load cell gear knob in this thing and we've got dual electronic throttle, that means that we can do the closed loop downshift throttle blipping. Basically, if you're downshifting it, we know the gear ratio because we can figure that out through engine speed and road speed or output shaft speed. From that, we can then blip the throttle up to what we think will be the RPM as you're downshifting through the gears. So it's amazing stuff. I just hope that we can convince this guy to use some of the paddle shifting stuff. If we can use, the Nexus has got all the auto trans control stuff in it as well. So you could put this thing in D for drive, a couple of air shifters up and down, and we're away. We've talked about engine sensors, we've talked about drive-by-wire, we've talked about gearbox control. I might have volunteered that we're going to do the body loom on this car as well. Headlights, tail lights, indicators, hazards.
Well, that's great because I brought my sleeping bag, so I'm actually going to sleep in the back of this car tonight, and got heaps of work to do. So that's mad. Thanks, man.
Well, I'm going to get configuring. I'm going to set up our indicators and headlights and tail lights and everything to work through this. I am going to set up the brake lights to work through the brake pressure switches, which is all awesome stuff. So basically, if you are absolutely hard on the brakes, we might even flash the taillights and put in some fancy stuff like that.
That's pretty cool.
Well, guys, we got a lot of work to do. We'll see you in the next episode.